Today, we're jumping into one of the most exciting frontiers in AI. We're talking about the quest to build an AI that actually, truly remembers. Moving beyond those simple chatbots and creating a real, persistent digital partner. So in this explainer, we're going to break down exactly how that's being done.
Okay, so you've totally been there, right? You have this great conversation with an AI assistant, you teach it something, and then the very next time you talk, it's a total clean slate. You're starting completely from scratch. Well, that super frustrating experience happens because most large language models are stateless. They just don't have a persistent memory of anything that happened before.
And this really highlights the big shift we're all seeing. On one side, you have the standard stateless model, but on the other, that's the goal, an agent with a real memory. It's really the difference between a tool you just pick up and use and a partner that actually grows with you. So let's get into how researchers are literally building that AI brain.
All right, first things first, where do you even put the memories? The AI needs a place to store all this information, kind of like a digital filing cabinet. And it turns out there are a few key ways to do this, and the way you structure that cabinet has a huge impact on how the AI thinks.
So the first major approach is something called token-level memory. It's the most straightforward idea, really. The AI basically writes down its memories as little snippets of text and then stores them in an external database. When it needs to remember something, it just goes and reads the right note from its filing cabinet. But, as you're about to see, how you organize those notes is, well, it's everything.
The simplest way is called flat memory. I want you to imagine just throwing every single note you write into one giant pile. It's incredibly easy and fast to add new memories. You just toss another piece of paper on top. But as that pile gets bigger and bigger, it just becomes this noisy, cluttered mess. Trying to find the one specific note you need, or even just seeing how two notes might be related, it becomes almost impossible.
So, a step up from that is planner memory. Now, instead of a messy pile, think of a mind map or a knowledge graph. Here, memories are nodes and they're explicitly linked to each other. This is great when the relationships between memories are just as important as the memories themselves, like, say, you're mapping out all the characters and plot twists in a novel. The downside, though, as you add more and more, you end up with one gigantic, tangled map that gets really expensive and complicated to manage.
And this brings us to the most sophisticated structure of all, hierarchical memory. This is like a professional-grade digital filing system, with folders inside of folders inside of folders. You can store the raw, nitty-gritty data at the bottom, summaries in the middle, and then high-level concepts way at the top. This is perfect for tasks that need abstraction, like an AI that has to summarize complex research papers by understanding both the fine details and the big picture. The trade-off, of course, is that it's just immensely complex to build and search through this.
So storing notes in external files, that's one way to do it. But what if we could make the memories part of the AI's core identity? What if remembering was less like reading a note and more like just knowing?
And this leads us to this really fascinating concept called parametric memory. Now here, knowledge isn't stored as text at all. It's encoded directly into the model's parameters, its internal network of weights and biases. Think of it like muscle memory. A pro athlete doesn't read a file on how to swing a bat. That skill is just deeply ingrained in them. That's exactly what parametric memory is trying to achieve for an AI.
Now, there are two main ways to pull this off. You can actually go in and modify the AI's core parameters, which is basically like retraining its entire brain. Or you can add a separate, smaller memory module, kind of like a plugin, that connects to the main brain but doesn't change its core structure. This gives you a nice balance between being adaptable and staying stable.
So we've seen the how, the different filing cabinets and brain structures, but let's just take a step back and ask why. What's the fundamental purpose of giving an AI a memory in the first place? What does it actually let the AI do?
Well, memory gives you three huge benefits. First up, it ensures consistency, so the agent remembers what it said before and doesn't contradict itself. Next, it enables coherence, which lets it follow a long, winding conversation and make the whole thing feel connected. And finally, it provides adaptability, so it learns your preferences and becomes a way more effective partner for you over time.
Now, to deliver on those three big promises, the agent's memory has to keep track of two very, very different kinds of information about the world.
First, you've got user factual memory. This is all about you, your name, your goals, the fact that you absolutely hate cilantro. This is the stuff that allows the agent to be personal and adaptive. And then there's environment factual memory. This is all about the task at hand. What's the current status of the code it's writing? Which people on the team have finished their tasks? This kind of memory is absolutely essential for actually getting things done in the real world.
Okay, so this is really important to get. Memory isn't just some static hard drive where you dump files. It's a living, dynamic process. It's not just about storing information. It's about managing it over time. And this is what's known as the memory lifecycle.
This lifecycle has 3 core stages. It all starts with memory formation, which is where the AI has to decide which little pieces of an interaction are actually important enough to save. Then comes memory evolution, where the memory bank is constantly being refined and reorganized, and we'll circle back to that in a sec. And finally, there's memory retrieval, which is the art of pulling out that perfect piece of information at exactly the right moment.
Let's zoom in on that middle step, memory evolution, because it's so much more than just hitting the save button. A healthy memory system is kind of like a well-tended garden. You can't just keep planting new stuff, you also have to prune and weed and organize everything to keep it healthy.
The source material we're looking at breaks this down into 3 key jobs. First is consolidation, which is all about taking new memories and integrating them to form bigger ideas. Then you have updating, which is absolutely crucial for correcting facts that just aren't true anymore. And finally, there's forgetting, the deliberate process of deleting memories that are useless or redundant.
And I really want to pause on this because it's a pretty profound idea. Forgetting isn't a bug, it's a feature. Seriously, an AI that remembered every single thing would be useless. It would just be bogged down by every trivial detail of every conversation it's ever had. So, smart forgetting, that is what keeps the memory system clean, efficient, and focused on what truly matters.
So, where does all this lead us? We've looked at the different ways to store memories, the reasons an AI needs memory, and that dynamic life cycle that keeps it all running. What's the big picture here?
By putting all these different memory structures and dynamic processes together, we're really seeing something new start to emerge. We're moving away from these stateless tools that just process text to true AI agents that can actually learn, adapt, and evolve right alongside us.
The research paper we're drawn from really puts it perfectly. This isn't just about getting better at finding old notes in a filing cabinet. It points to a future of generative reconstruction, where an AI might not just recall a memory, but actively synthesize it, reconstruct it, a lot like how our own human brains work.
And that leaves us with one last thought to chew on. As we get closer and closer to building an AI with a perfect, persistent memory, maybe the most important question isn't what we teach it to remember, but what we design it to forget. Thanks for joining this explainer.